Hello everyone, my name is Nikita and I am from the Bodhi Academy. In the last video, we had studied the lesson light and we had completed the chapter, the part reflection from the chapter light from the 10th standard science textbook. Today we are going to start the other half of the chapter, that is refraction. Okay, so what do we mean by refraction? To understand refraction, we need to first see how refraction is seen in the real life examples. Over here we can see that there is a glass of water and a pencil is immersed in the glass. Now we know that when a pencil is immersed, it should have appeared straight, right? The pencil should have appeared straight, but the pencil looks bent over here. The pencil looks bent. The reason for this is refraction, the phenomena refraction. The main reason is that the rays of light coming from the medium part of the pencil which is dipped inside the medium, which is immersed inside the medium, the rays travel from water to air. Okay, the rays travel from water to air. Now when we say water to air, these are two types of media. Now how do we differentiate media? We differentiate media by the means of its density. Water is a denser medium and air is a rarer medium. So the ray of light travels from a denser to a rarer medium, from one medium to another medium. When this happens, the speed of the light changes. Okay, the direction of propagation of light when it travels from first medium to second medium changes. The speed of the light changes, and this is the point where refraction happens, and this is the reason the pen part of the pencil immersed inside the water looks displaced. Okay, so this is one example of refraction. So now we understand what is refraction. Refraction is the changing the direction of propagation of light when it travels from one medium to another. And when we say medium, we consider its density. When it travels from a denser to a rarer medium or a rarer to a denser medium, the propagation of light, the speed and the direction of propagation of light changes. This is the point where refraction happens. Okay. Now when we consider refraction, again we have something called as laws of refraction. For the law of refraction, it is the same as the law of reflection. Okay, over here when we say reflected ray in terms of reflection, for refraction we say refracted ray. Okay, so the first law of refraction says that the incident ray, the refracted ray and the normal at the point of incidence, all these rays of light lie in the same plane. Okay, the refracted ray, the incident ray and the normal at the point of incidence all lie in the same plane. Now we know that the angle formed by incident ray and the normal is called as angle of incidence, and the angle formed by the normal and the reflected ray was called as the angle of reflection. Over here, the angle formed by the normal and the ray of refraction is called as angle of refraction. So the second law is called as the Snell's law. Is also called as the Snell's law, and it says that sine of angle of incidence, the ratio of sine of angle of incidence and the sine of angle of refraction is a constant for a given pair of media and for a given color of light. Now there can be two media. It can be water, air, water, alcohol. Okay, so when there are two media, for that particular pair of media, what sine of angle of incidence and what sine of angle of refraction is there, its ratio is always a constant number. It will not change, and this constant is called as the refractive index. Okay, so the sine of angle, the ratio of sine of angle of incidence and the sine of angle of refraction is a constant. This is the second law of reflection, which is also called as the Snell's law. Now, to understand refraction in a better way, we will study the diagram. Okay, for this purpose, the activity, one activity is done. Okay, a sheet of paper, a white sheet of paper is fixed on the drawing board using drawing pins, and over that paper rectangular glass slab is placed over the sheet. Now there are four identical pins are taken and two pins, okay, two pins are placed in this position. Now this is the glass slab, okay, it is placed on a white sheet of paper. This is the glass slab and there are four pins taken, okay, four pins are taken and two pins are attached over here, E and F point. Okay, now this is the glass slab. Now from the other side, okay, look for images of the pins E and F through the opposite edge. Now this edge of the glass is AB. Now from CD edge you have to see for the images of this pins. You have to see for the images of the pins. And wherever you can see the images of the pins on this side, from on that position you have to place the other two pins. Okay, so look for images of the pins E and F through the opposite edge. Fix the other two pins, say G and H, such that these pins and the images EF lie on a straight line. Okay, so wherever these were the original pins, this is where the object is placed. Now the image is formed this side. So the image, so for both the pins, the respective images will be G and H. They are placed on the other side. Okay. Now when they are placed on this side, the pins are now removed and they are marked. They are marked. And these markings are then joined. These markings are joined. Okay. So once you join the markings, so these markings are joined. Now when you join these markings, you have to draw a straight line over here, and wherever it is incident on the surface AB, there you mark the point as O. Okay, now go to the next one, G and H. You have to join these 2 points and draw a straight line, and wherever this line is incident on this edge CD, over there you draw a point O dash. Okay, now you have to join O and O dash. Now you have to remove the glass slab, and before that you have to draw an outline A, B, C, D, and then you have to join this line O to O dash. Okay, O to O dash. Okay, now what happens over here? Now wherever O is there, at that point you have to draw one normal. Okay, this one N to N dash, and wherever O dash is there, you have to draw the normal M to M dash. Okay, this one. Now this is the incident ray. This is the first incident ray which is incident on a surface, on a reflective surface. So it is forming an angle of incidence with the normal. So this is the first angle of incidence formed. Now over here there are two pair of media, right? There is air which is rarer and glass will be denser media. Okay, so now the ray of light is traveling from a rarer to a denser media. Whenever the ray of light is traveling from a rarer to denser media, it bends towards the normal. Okay, the ray of light is bending towards the normal. Okay, whenever the ray of light is entering from a rarer to denser media, I said that when it travels from from one media to the different media, there will be refraction happening. Refraction happens because this ray of light bends towards the normal. Okay, towards the normal means the ray, the direction of propagation of light and the speed of light changes in this media. Okay, because of refraction it changes and it bends towards the normal, then it goes. So this over here refraction is happening, right? At this point the refraction has happened. So this ray, this O to O dash, this ray becomes the refracted ray. Okay, now in the second condition, this refracted ray is now incident on the next reflecting surface, which is the CDH. The CDH, on that it is incident. So this became also my angle of incidence, but this is given as I2 because this is the second angle of incidence. Okay, now once it forms an angle of incidence, again over here when it has to come out of this media, of this glass, okay, it has to enter now the second media, which is the air. So again at this point what will take place is the refraction. Okay, over here refraction will take place, and when refraction is taking place in this condition, when the ray of light is traveling from a denser to a rarer media, it is moving away from the normal. Okay, it is going away from the normal and it is forming an angle of refraction over here. Okay, now it is emerging out. There is no other media over here. It is emerging out. So this ray O dash H, okay, O dash H is called as the emergent ray. It is called as the emergent ray. Okay, so over here we can understand refraction by this experiment, wherein the ray of light changes its direction of propagation when it travels from one media to another. For example, when it travels from rarer media to denser media, it bends towards the normal. Okay, when it goes from the denser media to rarer media, it bends away from the normal. And when it changes the direction of propagation of light from first media to second media, it is called as refraction. Okay, so this is the example of refraction, and these are the two laws of refraction. So this I was talking about the angle of incidence. This is the angle of incidence, this is the angle of refraction. The ratio of these two, the sine of this and then the ratio of these two, sine of these angles and the ratio of these two for this pair of media, for glass and air, will be constant. Okay, will be a constant, and this constant is called as the refractive index of the second medium to the first. So we have seen what is refraction. Now I will just introduce what do you mean by the okay, the reflection was done by the mirrors. Now who is responsible for actually doing the refraction? Okay, so for refraction we use the lenses. Now what is a lens? Lens is a object wherein at least one of the, it has two reflecting surfaces. Okay, it has two reflecting surfaces and either of them will be spherical. Okay, so for refraction we have lenses, and for lens, how it is different from a mirror? It has two So I will just introduce to you now the two lenses. Okay. So among them, first one we have is the convex lens. The second one is the concave lens. The convex lens is the one wherein both the reflecting surfaces are curved outwards. Okay, they are bulging outwards. So this is the first reflecting surface and this is the second reflecting surface. This is the center part. Okay, both are curved outwards. This is called a double convex lens or simply a convex lens. The second lens is the concave lens wherein both the reflecting surfaces are curved inwards. They are curved inwards and this is called as the concave lens. Okay, so concave, so it is like a cave, right? The shape, so it is called as the concave lens and this is called as the convex lens. Now, how it is different from a mirror? A convex lens, for a lens, I will just take an example of a convex lens over here. The center of the lens is called as the optical center. For mirror, the center of the reflecting surface was called as the pole. Over here, it is called as the optical center. Okay, this is the principal axis which remains the same. Then it has a focus, principal focus. This reflecting surface will have this principal focus and this reflecting surface will have this principal focus. So as there are two reflecting surfaces, there will be two principal foci for the lens. Now, when there are two principal focus, because there are two reflecting surfaces, so definitely there will be two center of curvatures. Okay, two center of curvatures. This is called as C1 and this is called as C2. This are also called as 2F1 and 2F2. Why it is called 2F1? Because we know that center of curvature is twice the focal length. Okay, so this was a short introduction of the concave and the convex lens and how it is different from the mirror. We will be studying in detail about the lenses, the refraction and image formation in the next videos. Okay, so thank you for watching my video. Please like, share and subscribe to our channel.